The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example, friction on inclined plane. What force must Janus's motorcycle apply to get up the 45-degree incline if the motorcycle accelerates 4 meters per second square? Incline has friction of 1100 newtons. Mass total for Janus and motorcycle is 220 kilograms here. Again, we will label directionality positive, going up and to the right. Okay, that is a terrible looking plus sign. Okay, there we are. Now let's begin here just by writing down our givens. It's just good to know what's going on. Again, like I always say, it's never a bad idea to write down little g, which is just 9.8 meters per second square. We're also being given mass here, right, which is, what is mass? 220 kilograms, right? Let's just fix that, K. Now, we're also being given, we also have frictional force this time, so that's going to save us some time, right? And that's going to be 1100 newtons. Wonderful. We also have acceleration. Great. That's going to be 4.0 meters per second square. And we have, we also have our angle here, which is 45 degrees. Wonderful. And what is it that we're looking for? We're actually looking for force applied. We'll call that the force from the motorcycle, right? Great. Let's begin by drawing ourselves here a free body diagram. Okay, great. Wonderful. So we'll begin here, and again, we said to the right is positive. Thus, we're going to have what we're looking for is the force applied, right? That's going up the incline as such. That's what thus force applied, that's what we're interested in, right? There's going to be a frictional force as well. Now, there's also going to be a normal force. And we're going to have the force of gravity as such. Now, again, because the axis here is rotated, we'll go ahead and break the force of gravity right down into its components. Wonderful. And the perpendicular component for the force of gravity is just going to be mg cosine theta, and before I forget the angle in here, that is also just 45 degrees, right? Perfect. And the parallel component to the force of gravity, that is just going to be mg sine theta. Wonderful. Now that, and one other thing that I would just quickly like to mention here is we know that force net y, because there is no acceleration along y, that force net y is just going to be 0. Thus, in order for us to find, we can go straight to the force net x, and force net x is just going to be force applied, because direction again is to the right, we said it's positive going up, right? We said it's positive moving up, so it's going to be the frictional force and the parallel component to the force of gravity, they're both going to be negative, and the force applied is going to be positive. We have mass, we also have acceleration.